This video will go over section 8.5 on concentration units. So what is the concentration of a solution? It is the amount of solute dissolved in a specific amount of solution. So if you write this in a mathematical form, it's the amount of solute over the amount of solution. And so this allows to quantify how much solute you have per amount of solution. And so there are many different types of concentration units, and we will explore only a few. Here, this summarizes the main concentrations that are used. The mass percent, and the symbol is m/m in parentheses, would take an amount of solute in grams over the amount of solution in grams times 100. We will not use that unit in this course. We will use the rest of them. So volume percent with the symbol V/V in parentheses. The volume percent will be given in milliliters of solute over milliliters of solution times 100. Mass per volume percent is when you take the amount of solute in grams in an amount of solution in milliliters. And so the symbol is M/V in parentheses because it's mass per volume. And then the molarity is a very typical chemistry unit. The symbol is capital M, and the amount of solute is in moles per liter of solutions. So we'll see that the volume percent is typically used for liquids dissolved in liquids because it's in milliliters over milliliters. So like aqueous ethanol solutions, like wine, typically is given in the alcohol amount is given in a percentage in volume percent. The mass per volume percent is typically given for solids dissolved in liquid because solids then are measured in grams and in a liquid in milliliters. So like IV solutions, intravenous solutions of salt dissolved in water typically will be given in a mass per volume percent. And then molarity, as I said, is used mostly in chemistry labs because it gives a number of moles per liter of solution, which is convenient when you do chemistry calculations. So let's go over volume per volume percent or volume percent. V/V is the volume in milliliters of solute over the volume of solution in milliliters. So the formula is volume percent is volume of solute over the volume of solution times 100. The two volumes have to be in the same units. So milliliters or both liters. It will work out because they cancel out. And times 100. So don't forget to multiply by 100 because this is a percentage. So volume percent can be used as a conversion factor for volume of solute in 100 milliliters of solution. So you would use that as a equality that says a number of volume of solute equals 100 milliliters of solution. So that's how you would use it. Because the volume percent can be also calculated as the milliliters of solute if you have exactly 100 milliliters of solution, right? And in this case, you would not multiply by 100 because you already have exactly 100 milliliters of solution. So volume percent is used for liquids dissolved in liquids because it makes sense to have, milliliters over milliliters then. For example, in the kitchen, we see a lot of volume percent. For example, a bottle of vanilla extract is 35% alcohol by volume. So that 35% alcohol by volume, the way you want to read that is that you have 35, so it says by volume. So you want to say it's 35 milliliters of alcohol because alcohol here is the solute. So 35 milliliters of alcohol in, because it's a percentage, in 100 milliliters of vanilla solution. The vanilla extract is your solution. It's the whole thing together. And the 35% is measuring the amount of alcohol in that solution. So that's how you want to interpret volume percent. So let's calculate a volume percent concentration. And here it's going to be lemon extract. A bottle contains 59 milliliters of lemon extract solution. If the extract contains 49 milliliters of alcohol, what is the volume percent of the alcohol in the solution? So here it specifies that lemon extract is a mixture of lemon flavor and alcohol, right? And so we want to know the volume percent of alcohol in that mixture. So alcohol is the solute we are interested in, and we want to know how much alcohol in percentage there is in the solution. So if we use the usual way of solving problems where first you want to extract the given information, and so here there's two numbers, and so you need to make sure you identify correctly the solute or the solution or the solvent if sometimes you're given the volume of solvent. So 49 milliliters of alcohol, that's your solute. And 59 milliliters of solution, lemon extract is your solution. So you have the volume of solute and the volume of the solution. Solution, remember, is the solute plus the solvent added together, right? It's the whole thing, it's the mixture. So what is needed here? It's asking for the volume percent of alcohol in the solution. So we need the volume percent formula that says you need the volume of solute over the volume of solution times 100. So it's just plugging in the values into this formula because both volumes are given with the same unit. So you can just plug in the values. So if you plug in the values, you have 49 milliliters of alcohol, that's our solute, over 59 milliliters of solution, that's our lemon extract, times 100. So in the calculator, it's 49 divided by 59 times 100, and the calculator answer is 83.05, etc. Here, as always, you need to pay attention to significant figures, and we have two sig figs in both measurements. The 100 is always an exact number, will never limit your amount of sig figs. So we are limited to two sig figs from both given measurements here. So keep the 8 and the 3 and write down the unit of percent, parentheses V/V, close parentheses, and we call that an alcohol solution. The way we name it is that you give the name of the solute and you say it's a solution of that. So 83% volume percent of alcohol solution. Let's do a learning check where you will try on your own before you watch the answer. So the problem is, what is the volume percent, so V/V, of Br2, bromine, in a solution prepared by dissolving 12 milliliters of liquid bromine in the solvent carbon tetrachloride, CCl4, to make 250 milliliters of solution. So as always, you want to extract the information from the text. And here we are given 12 milliliters of liquid bromine. And so the bromine here is your solute. You're making a solution with it by dissolving it into a carbon tetrachloride. Carbon tetrachloride is your solvent. So together, bromine plus carbon tetrachloride are making a solution. And we are given the volume of the solution, 250 milliliters of the mixture. So the question is asking, what is the volume percent of Br2 in this solution? So we need the volume percent. You get the formula out. And by the way, this is in your reference packet. I will show that in a second. So when you have your reference packet, the formulas to calculate volume percent, mass percent, and molarity and dilution are all in that first page of the reference packet for Chem 121. Here at the bottom of the page. So the page here has, chapter 7 stuff here on the right side, and then chapter 6 on the left side. And then below that, it's chapter 8 with the volume, mass per volume percent first, then the volume percent is here, volume of solute over volume of solution times 100. And there is the molarity formula, the dilution formula. So we have our formula now, and we will now substitute the values because they are both in milliliters, so we can just plug in the values. So you have the solute on top, 12 milliliters of bromine, and the 250 meters of solution in the bottom, times 100. When you do this in your calculator, so 12 divided by 250 times 100, the calculator answer is exactly 4.8. It happens to be 2 sig figs, which is what we need because in 12 milliliters here we have 2 sig figs. 250, there is also 2 sig figs, right? The 0 is not significant. And the 100% is not limiting, it's an exact number. So you want to keep 2 sig figs, and so you keep the 4 and the 8. And the unit is percent V/V, and we would name it bromine solution, right? You say the solute, and you say it's in a solution. So 4.8% volume percent of bromine solution. So the other concentration unit we will explore in detail now is the mass per volume percent. The mass per volume percent, M/V, is the mass of solute in grams to the volume of solution in milliliters. So the formula, again, that you take from the reference packet is mass per volume percent is the mass of solute over volume of solution times 100. And here you have no choice but to have grams of solute over milliliters of solution. So the mass per volume percent can be used as a conversion factor for mass of solute dissolved in 100 milliliters of solution. So when you're given a mass per volume percent, you can read it as a mass of solute in grams equals 100 milliliters of solution. Because if you have exactly 100 milliliters of solution, for example, then it would be just the grams of solute over the 100 milliliters of solution. And you would not need to multiply by 100 if your volume of solution is exactly 100 milliliters. So mass per volume percent is widely used in hospitals and pharmacies for preparation of medicines and intravenous solutions. For example, 5% mass per volume solution of glucose that's usually given to patients who need to be nourished intravenously. And so what it means, it's that 5% by mass per volume means you have 5 grams. So because it's mass per volume, so grams of solute. The solute is the glucose here. So 5 grams of glucose in, and it's a percentage. So in exactly 100 milliliters of solution. So that's how you would want to interpret that 5% per mass per volume. It's 5 grams of glucose in 100 milliliters of solution. And this can be used as an equality that says 5 grams of glucose equals 100 milliliters of solution. So let's go through how to calculate a mass per volume percent concentration. So the problem is saying that we have a potassium iodide solution that may be added to a diet that is low in iodine. A Ki solution is prepared by dissolving 5.0 grams of Ki in enough water to give a final volume of 250 milliliters. So what is the mass volume percent of the Ki solution, potassium iodide? So here you have some pictures on the right that show what we call a volumetric flask. A volumetric flask is this kind of flask with a wide bottom, wide and round bottom, and then a very long neck. These are very carefully calibrated, and they have a line. You can see the line in the like bottom. So the line you see etched or painted on the side of the neck represents exactly where you will have 250 milliliters. If this flask is calibrated to hold 250 milliliters, then the line here is telling you that when the meniscus of the liquid sits on that line, you have exactly 250.00 milliliters. It's a very precise volume. They are calibrated precisely. So, and we use this volumetric flask to make solutions. And so the way you would do this potassium iodide solution is that you would, on a balance, take 5 grams of potassium iodide. So it's a salt, it's crystals, white crystals. Then you would slide them inside the volumetric flask. And so that's what you see at the bottom here, the bottom of the left volumetric flask. And then you would add some water. At first you would only fill the flask halfway, and then swirl the flask to dissolve all the salt. And then once all the salt is dissolved, you would finish filling the flask to the line where the meniscus should be just sitting on the line. You know, you remember how the bottom of the meniscus is supposed to be on, you know, aligned with the line. And by doing this, you know you would have exactly 250 milliliters of solution. So here we have a problem where we need to calculate the mass per volume percent of the potassium iodide solution when it's prepared by dissolving 5 grams of Ki in enough water to give a final volume of 250 milliliters. So as always, you want to extract the information from the text. And here the given amount is 5 grams of Ki. Ki is your solute, the salt we dissolved in water. And we have a final volume of solution of 250 milliliters. So that's grams of solute in milliliters of solution, and we need to find the mass per volume percent. So you would take out the formula from the reference packet, and that says that mass per volume percent is the mass of solute over the volume of solution times 100. So we have our mass of solute in grams, volume of solutions in milliliters, so we can plug in the values. So it's 5.0 grams of Ki on the numerator over 250 milliliters in the denominator. times 100. When you do this on your calculator, it's exactly 2, but the calculator doesn't know about significant figures, so you have to pay attention to significant figures. And here, as always, 100% is an exact number, not limiting the number of sig figs. In the numerator here, we have 2 sig figs in the 5.0 grams. And the 250 meters also has 2 sig figs because the 0 is not significant. So we need to keep 2 significant figures, and so then you need to add 0.0. So it's 2.0% mass per volume Ki solution. Remember how we name it? We tell the solute name and then say that it's in solution.